Hey students, this is lesson 112, decreasing linear relationships. Yesterday we did a situation where Michaela was delivering pamphlets at a rate of 150 per hour, and that's this situation. And so every hour on Sunday she had delivered 150 more, so these numbers keep going up by 150. And notice that both the hours and the Sunday deliveries are increasing. In other words, the numbers keep getting higher. That's called an increasing situation. All right? We are now going to talk about decreasing situations in lesson 112. Okay, so here's the situation. Suppose Michaela started with 1,000 pamphlets on Saturday, and on Saturday she delivered 350 of them. So she has already delivered 350 on Saturday. On Sunday, she delivered the remaining pamphlets at a constant rate of 150 an hour. So the rate is the same as it was before. But, so how many pamphlets did Michaela have left to deliver when she began work on Sunday? So she had to do 1,000 total. And on Saturday, she delivered 350 of them, so we want to subtract those two, and that means she has 650 left remaining to deliver. All right? So right here, when we fill this out, we're talking about the pamphlets remaining to deliver when she starts work on Sunday. Well, on Saturday, she delivered 350, so that means she has 650 left. And every hour she delivers 150 more. So I'm going to subtract 150 for each hour. So 650 minus 150 is 500, minus 150 is 350, minus 150 is 200, minus 150 is 50. So that's the situation here. Notice as the hours goes up, so as these increase, these numbers are decreasing. This is an example of a decreasing situation. Okay, now to write an equation to represent this, again, she's delivering 150 per hour. So if I multiply my number of hours times 150, what I would need to do in this case is subtract that from 650. So we can do this a couple of ways. We could write the pamphlets remaining is equal to 650 minus 150, but I need to subtract 150 for every hour, so I need to multiply that by the number of hours. Or I could, since it's going down, I could just put a negative sign in front of the 150 because I'm taking that off every hour. And then to get it to start at 650, I would just add 650 in the equation. So either of those equations will work. Then part number 4 says, after how many hours did she run out of pamphlets? Well, notice that at hour 4 she's at 50, and if we subtract 150 one more time, she's going to be running out of pamphlets. So, so somewhere between 4 and 5 hours. So at 4 hours, she still has 50 left to deliver, but at 5 hours she would be in the negative. So somewhere between 4 and 5 hours. All right, and then it says draw a graph of this relationship. We're just going to take these points and graph them. So first point is 0, 650, and that would be right here. The second point is 1, 500, that would be here. 2, 350, 3, 200, 4, 50, 5. If I subtracted 150 from 50, I would actually be at negative 100 right here. So that would be there. And then I want to draw a line in there because this relationship is, she's continuously delivering pamphlets. So that's going to look like that. Is the relationship linear? Definitely. It's a straight line. All right. How is your graph different from the graphs you made in investigation 1? What about the situation causes this difference? The graph is different because in investigation 1, remember the lines kind of went this way, all of them. So when both numbers are increasing, the line goes up from left to right. So now that this graph is different because the graph goes down from left to right. And that's how you identify a decreasing situation from the graph. If the line is going down, as the x values go up, the line is going down. Okay, is the number of pamphlets remaining directly proportional to the number of hours Michaela worked on Sunday? That is the relationship a direct variation? Explain how you know. Okay, what we want to do here to see if it's a direct variation is see if we get the same ratio. So notice there's a couple ways we can know, but after 1 hour, she still had 500 remaining. So we would want to do 500 divided by 1, which is 500. At 2 hours, she had 350 remaining. 350 divided by 2 is 175. These numbers are not proportional. So right away, we would say, no, they're not. So it's not a direct variation. We do not have the same ratio. Or you have another choice. You could tell by this on your table right here. All direct variations have to start at 0, 0 to keep the numbers proportional. So another reason you could put for that is, and I'll just put also, data doesn't include the point 0, 0. In other words, this line does not go through the origin. So that's actually another way you could say, look at the graph. This line definitely, it would have to go through that point right there, the origin, for this to be a direct variation. Okay, consider the equation you wrote in exercise 3. In your equation, you should have added negative 150h or subtracted 150h. What does the negative symbol or the minus sign before 150 indicate about the situation? How does it affect the graph? It indicates that the total is decreasing. The y values are decreasing, or the total, whatever, in this case it's r. The output is decreasing. All right. How does it affect the graph? It will slant. The graph slants down from left to right. Okay, your equation should also have the number 650 in it. What does 650 indicate about the situation? I think I need to go back to our table here and notice right here that when we worked 0 hours on Sunday, 650 is the number of pamphlets remaining. So it's how many, it's the output when the input is 0. So it's the y value when the input is 0. Also notice on the graph, it's right on the y-axis where we start. So some of you learned last year that that's called the y-intercept. So we can say this a couple of ways. It's the y-intercept. It's the value, the output value when the input is 0. So y value when x is 0. All right. To finish this up, I'm going to let you think about your answer to number 9. And I'd like you to do that and have an answer prepared for tomorrow, and then we'll discuss that in class. All right. See you tomorrow.